So on problem 2, note that your formulas up above have nothing more than a constant on top. Currently they all have 1s, but of course we could pull the constant out in front. So there's nothing on top. So I certainly don't want this plus thing on top. But I know when I have fractions where there's more than one item on top that I can separate it. So I'm going to try separating it first. We'll see where this leads. And of course, on this second one, I'll actually be able to pull that 2 out in front. And then that actually fits my pattern. Now, here's what I do note, is that it looks like I have a constant squared minus my variable squared. So the second one already fits a pattern, but the first one, I still have a problem in that I have x on top. And so the only other strategy that I know of to try at the moment with that is, what if I let u equal that stuff in the denominator? And when I do that, I'll get negative 2x dx, and then I say, ooh, all I need to do is add a negative 2, so a negative 1/2. So I'll have negative 1/2, the integral, keeping in mind that all of this stuff is now du over u to the 1/2. And I can actually integrate that. And over here, I've got dx over 2 squared minus x squared, and I can integrate that. So this first one, of course, I'll be powering back up, so that'll be u to the positive 1/2 over 1/2, which is times a 2. And this one is, now keep in mind, this is really an a squared minus a u squared, because that's going to help me. So when I look at it, it fits the first formula up above, which is arc sine of u, which would be the x, over a. And then I don't want to forget my vitamin C. And so the first one's going to simplify to that. And then I can substitute back in my u for this first piece. So I get my final answer. Now, if you keep in mind that you're looking for perfect squares, then whenever you have a quadratic in the denominator, you're going to want to see if you can turn that into a perfect square. Because when I look at the second formula up above for the arctangent, I notice that that's not inside of a radical. And hopefully you remember how to complete the square. So you take half of that b value and square it. So that's going to give me 4. And I can't just go around adding 4 to both sides, but I could add a total of 0 by doing a plus 4 and a minus 4. That's legal. And so now in front, those 3 terms form a perfect square of x minus 2 squared. And these last 2 form 3. So now substituting in its new name, it looks like that. And you're probably thinking, well, but Torres, you don't have 2 perfect squares. And I say, well, wait, couldn't I make this be 2 perfect squares? I got a little math magic here in up my sleeve. If I rewrite it like this, isn't it now 2 perfect squares? And that's where you say, Torres, you're a genius. I know, right? So keep in mind that this is the variable and this is the constant, so that when I get ready to do 1 over a and then arctan of u over a plus c, and I don't think I can simplify, so it looks like that.